we're going to be going over solving systems of equations and inequalities, but this one will be more complicated.
All right, so our goal for today, we're gonna be solving for both variables in a system of equations or inequalities. And we're also gonna review how to solve equations and inequalities for one variable from last week's lesson. So we're gonna start off with a warm-up, just a quick 5 problems. We'll give you guys 10 minutes to do this. So go ahead and start doing them.
Yes, it's a system of equations. So if you know how to solve it, go ahead. If you don't yet, that's what we're going to cover it. We're going to cover that today.
Alright, you guys should have had enough time to do your warm-ups.
How
So
far are
now
you
we're
guys? Are most of you guys like almost done, or you guys still need a little bit more time? I'll take that as a pretty much done. Okay. So let's start with number one. This one is what we covered last week. So let me turn on the annotation. All right, do you guys need me to write out the question, the work, or do you guys just want the answers? Okay, I'll just start with the work then. So for number one, this is exactly what we did last week. So first step, you distribute the left side. So that turns into 3x minus 12. On the right side, you also distribute. That turns into negative 4x plus 2. Right, then you can move all the x to one side of the equation. So we can add 4x to both sides. That turns into 7x minus 12 is equal to 2. Now to isolate the variable, we can move the negative 12 over to the other side by adding 12 to both sides. That turns into 7x is equal to 14. And then now lastly, we can divide by the coefficient, which is just a number in the front. And then the 7, so it turns into x is equal to 2. That's the first problem. Are there any questions? Okay. All right, so the second question. So, hold on. First step, you can bring all the variables to one side, so you can subtract 4x from both sides. That turns into 4x plus 6 equals to negative 14. Then you can move all the constants to one side. So you subtract 6 from both sides. So it turns into 4x equals to negative 20, right? And then you can divide by the coefficient, which is 4. And then that turns into x is equal to negative 5. So that's the answer for number 2. Are there any questions for this problem? Okay. So for number 3, for this problem, this is just main point of this one is just to be careful with your parentheses. So for this, you can distribute the negative, right? Because you're subtracting this entire everything in the parentheses, right? That turns to 7 minus 5x plus 13. I think some of you guys may or may not have mixed that up, but the rest I say is the same for now. You combine the constants, which are just these numbers without the variables on the left side. So it turns into 20 minus 5x, which equals to negative 25. Then from here, you can subtract 20 from both sides to get rid of this constant to isolate the variable. So that turns into negative 5x is equal to negative 45. Lastly, you can divide by the coefficient, which is negative 5. So you divide both sides by negative 5, and you'll end up with x is equal to 9. Were there any questions for this problem? Okay. So let's move on to number 4 now. So this one's an inequality, so you won't you'll get a range for an answer. So the first step, like we always done, we just distribute the 3 into the parentheses, so that turns into negative 21p minus 15 is less than negative 20, less than 27. So the right side stays the same. Next step, we isolate the variable, which is p, and we move the constant, which is 15, to the other side. And we can do that by adding 15 to both sides. So that turns into negative 21p is less than or equal to 42. Right? And then after that, you can divide by the coefficient right here. So that's just negative 21. So you divide both sides by negative 21. That turns into p is greater than or equal to negative 2. And this is where some of you guys may have or may not have messed up again. This is when we divide, just keep in mind when we divide or multiply by a negative number that we need to be careful and switch the sign over. So if it's less than or equal to, we turn into greater than or equal to, like in this problem right here. Were there any questions for this one? Also, if you guys have any questions while I'm working through the problems or anything, you can just go ahead and unmute and speak up. And yeah. So last one is number 5. This one is a problem that we'll be kind of explaining to you guys how to do today. And if you guys didn't know how to do it, it's fine. And I'll just write out the explanation, and we'll explain it more in detail later, this type of problem. But for now, yeah, let's just get into it. So it's the original problem. For this one, we can use a method called elimination, which we'll talk about later. So for this one, you can multiply this equation, both sides, the top by 2 to make it easier to set it up for the equation. So this turns into 8x plus 6y is equal to negative 16. And then we keep the bottom the same. So from here, we can add the two equations together. So just imagine like a plus sign here and a plus sign here and a plus sign here. So this turns into 8x plus negative 8x is just equal to 0, right? So we can just take that out for now. This cancels out. And 6y plus y is equal to 7y. And then the last part, when you add these two together, you end up with negative 28. And then when you divide by the coefficient like we've done in all other warm-up problems, we end up with y is equal to negative 4. Now we have the y, we have the solution for y, right? But then there's 2 variables in this problem, so we also need to solve for x. So here we can plug everything back into the original equation, right? Which is, let's just use 4x plus 3y is equal to negative 8, right? And then now we can go to apply the concept which we have worked on last week and which the other questions in the warm-up have been using. So we just plug in y here, right? Because we know y is equal to negative 4. So we just put negative 4 for y instead in the place of y, which we can call a substitution. Then this turns into 4x minus 12, right? Because 3 times negative 4 is negative 12. This turns into, the right hand still stays a negative 8. And here, like we have been doing earlier, we can isolate the variable by moving the constant over. So, oops, that turns into 4x is equal to 4. We divide by the coefficient, which is 4, and that just turns into x is equal to 1. So the answer would just be x is equal to 1 and y equals to negative 4. So this is just like kind of a preview to what we'll be teaching you guys today. So if you have questions and if you're confused, don't worry about it. We'll explain them more in detail. All right.
All right, so today's lesson is going to be, all right, well, first we need to review solving equations and inequalities with one variable. So the things you need to note for today's lesson, 3 properties to remember. As you learned last week, there's the associative property, which is when a number can be added or multiplied regardless of how they are grouped. The commutative property, so when adding or multiplying, changing the order of the numbers will not change the resulting value. And then the distributive property, where multiplying a number by another group of numbers added together is also the same as doing each multiplication separately. And we're also going to go over inequalities. The main thing to note is just when you multiply or divide both sides of an inequality by a negative number, you must flip the inequality sign. All right. So solving a system of equations. For example, as you also saw in the review, something like x plus y equals 8, and then y equals negative 2. Like in this example, y is already solved, but we also need to solve for x because when we solve for a system of equations, we're actually trying to find a single point or multiple points on where these 2 lines intersect on the graph. So there's two methods for solving a system of equation. There's the substitution method and the elimination method, which we'll get into later. There's also different ways to tell whether an equation has no solution, one solution, or infinitely many solutions. So if you look at the three examples on the bottom, no solution, if you have x plus y equals 5, and then you have 2x plus 2y equals 11. So if you make these two the same, like, if you remember from last week's lesson, how you can multiply, when you multiply or change one side of the equation, you must do it to the other side. So if you multiply this first equation by 2, you'll get 2x plus 2y equals to 10, while the other one is equal to 11. So while these two are the same, this constant number is different. So the numbers with the coefficients, those are like the graph. Those are like how the graph will look like. So the slope of the line on the graph will look the same, except the constant makes it never intersecting each other, which makes this have no solution. And then for one solution, you have 2x plus y equals 8, and then 3x plus 2y equals 14. This is kind of just the same thing that we did in our warm-up, where you'll have one x value and one y value, which will act as your coordinate for the answer. And then for infinitely many solutions, it's the same concept as no solution, except when you make both coefficients the same, the constant is also the same. That means they're both the same line. So does anyone have any questions about this?
No.
Alright. Okay, moving on. So we have new concepts on how to solve these system of equations. The first one is going to be substitution. So when we solve something with substitution, we find the value of a variable, then we plug that value back into the problem in place of the variable, as Matthew showed in the warm-up. We found y, then we plugged y back into x plus y equation to find x. For elimination, when we solve for something with elimination, we're either gonna add or subtract the equations from one another to solve for one variable. So we're just gonna get rid of one of them and solve for the other one. And then we're gonna give some examples on how to solve these.
So for this problem, we're going to be using substitution. So since we have in this equation right here, we already have technically the value of x, right? We know that x is equal to 3y plus 2, right? So that means the value of the two of them will have to be the same. So here in the second equation, we could swap it in, right? So for x right here, we just plug 3y plus 2 in for that, right? Alan, what did you send? Okay. Yeah, so you just plug that in and turn the 6y is equal to 3y plus 2 plus 7 right here. And then we can simplify that easily by just putting the constants together, and we end up with 6y is equal to 3y plus 9. So then we can isolate the variable, right? to allow us to solve for the problem. So by subtracting 3y from both sides, we end up with 3y is equal to 9. That's after we simplify. And then like we've been doing, we can solve for y by dividing by the coefficient in front. And then we end up with y equals to 3, right? So now we have y equals to 3. We have the value of y, but we still don't have the value of x, right? And we know what x is equal to, and it's in terms of y, right? So we can plug y back in. So that turns into x is equal to 3 times 3 plus 2, right? And we end up with this answer, which x is equal to 11. So we use substitution to solve problems because we cannot solve for two variables at the same time. So we isolate for one and then we solve for that, right? In terms of the other one. So in a sense, we're just turning the system of equations with two variables right here into the type of equation that we've been solving last week. So it should be something that you're decently comfortable with. I think the main problem, or for you guys now, is just to manipulate the equation to fit the variable in. But for most of the problems, they should be relatively simple. And yeah, are there any questions about this about substitution so far? All right. If not, we can move on, I guess. All right, so the next problem we'll be working on will be using elimination, and this is what the main the solving method that I used in the warmups. So for this problem here, I rewrote this. This is the problem, right? And I rewrote it to make it easier for us to eliminate a variable, just to make it easier to like look at and find out what to do. So we can subtract the two equations from each other, right? Because we have x on this side and x here. So when we subtract them, we'd subtract 3y from 6y, and we subtract 3y plus 2 from 6y, and we subtract x from x plus 7, right? So the equation would be something like this. So we just subtract the two equations from each other, and we would end up with what we have here. So what's left? We don't have any more x variables left in the equation. So it just turned into a simple equation, which we've been doing since last week that you guys can easily solve for.
I
We
think
isolate y.
for
What's up?
this case, the substitution would be better since it already puts x by itself.
Yeah, this is the same problem that we just solved in the earlier problem. This is the exact same thing. We're just using elimination just to show you how it works. So in this problem, yeah, I agree that substitution would be the most efficient way, but it's also good to understand elimination for problems that aren't so easy to deal with. Elimination is not necessarily harder. It's just there's less problems that it's easier to use for. Yeah, it depends on the question. You're right. Okay, so are there any questions so far? Actually, to finish out this problem, we have solved for y after the elimination, but then we implement substitution again at the very end. It's just in a simpler method. Since we have y, we plug y back into this original equation to find the value of x. So 3 times 3, which is y, plus 2 would equal to x, and x comes out to be 11. Are there any questions? All
Right. So we're gonna get into a few problems regarding how many solutions each question has. So if you remember from what I told you earlier, if the coefficients are the same but the constants are different, then the equation will have no solution. But if the coefficients are the same and the constants are also the same, then the equation will have infinitely many solutions. And if the coefficients are different and the constants are different, then you'll have one solution. So I want you guys to try and figure out how many solutions the system of equation actually has. I'll give you guys about 2 minutes. Alright, so does anyone know how many solutions the system of equations has?
I think it's 0.
Yeah. Why do you think it's 0?
Because once I solved it, the two equations become 4y is equal to 12x subtracted by 10. And the second equation is 4y is equal to 12x plus 28, which is different from the first.
Yeah, correct. So we're gonna clarify for anyone that doesn't understand. We're gonna help you guys distribute this out and show you why. Okay, so for the first one, we're gonna have 12x. We're gonna distribute this out and we're gonna get 12x minus 4y minus 10 is equal to 0. And the other one is gonna become negative 3x plus y minus 7 is equal to 0. So now we're gonna put x and y together and put the constants on the other side to make this a little easier to solve. So we have 12x minus 4y is equal to 10, and then negative 3x plus y is equal to 7. And then if we multiply the negative 3x plus y is equal to 7 by 4, or by negative 4, we're gonna get the same coefficients as the first equation. So we'll have 12x minus 4y, but then we have to multiply 7 by negative 4, so that'll become negative 28. Yeah, so as you can see, the coefficients are the same, except the constants are different. Therefore, this system of equations has no solution. All right, does anyone have any questions?
No.
Okay. Okay, we're gonna move on. So again, we're gonna have the same thing, but it's a different set of numbers. I'll give you guys 2 minutes to solve this one as well. Okay. So for this one, does anyone know how many solutions there are?
2 solutions. One is x is equal to 4. The other is y is equal to 0.
Yeah. So we're gonna distribute this out for anyone that doesn't see. So first we have to distribute all the parentheses. So it's gonna be the first question is gonna be 12. Wait, 12y plus 4x is equal to 24 plus 2x. And then we're gonna combine 24 plus 2x. And then we're gonna combine like terms. So we're gonna have 12y plus 6x is equal to 24. And then for the other equation, we have 2x is equal to 8 plus 4y. Wait.
Did you guys all get to this point? Could y'all like maybe type something in chat if you guys at least got the distribution? I just want to make sure everyone's on the same page right now, because we're gonna probably have to do a Kahoot at the end, so I don't want anyone to feel left out then.
Okay, if we continue on, we're gonna have
Actually, I think we should be fine with the skipping this problem. We have a lot more material to cover, and then we have still have the Kahoot at the end. So let's just skip this problem for now. We can come back over time because we're running out of time for the concepts.
yeah, but there is 2 solutions for this question if you didn't get that. Okay. Moving on, we can just practice a little bit.
All right, so this problem was the one we did for our warm up. So now that we've kind of covered the concepts, if you guys don't remember the answer, please do give it a try. See if you guys understand more than you guys did earlier. We'll give you 2 minutes or a minute for the problem because we have to move pretty fast now. All right, so I think that should have been enough time. And if you guys don't, the solutions should be on the screen for you guys. So what we covered earlier was the elimination method, which we did in the warm up. So I manipulated this first equation and multiplied both sides by 2, turn into 8x plus 6y equals to negative 16. And then we added both equations together to cancel out the x. So all we're left with is 7y equals to negative 28. And then from that, we get y is equal to negative 4. All right, and then we can plug that into the original solution here to solve for x, and we end up with x is equal to 1. And that's the elimination method, which I personally think might be simpler for this problem, but you can also do it with substitution for pretty much any problem. You can do it either way, just whatever is more convenient or whatever you guys see first. So for this one, I took the second equation here, negative 8x plus y is equal to negative 12, since y does not have a coefficient in front of it. So I solve for y, and y is equal to 8x minus 12. All right, so I added 8x to both sides to cancel out, just isolate the y variable. So from there, we know what y is equal to, right? This has the same value as this. So we can substitute that back into our other equation. So 4x plus 3 times 8x minus 12, right? So we replaced y with that. It's just equal to negative 8. So the right side doesn't change, but the left side, we distribute the 3 into the parentheses right here. And then we end up with 4x plus 24x minus 36 is equal to negative 8. And then we can simplify that, and we end up with 28x minus 36 is equal to negative 8. Right, then we can add 36 to both sides to isolate the variable here. We end up with 28x is equal to 28. And then from that, we can clearly see that x is equal to 1. So from there, we can carry on the x and plug it into our original equation up here. So I used the one where y was already isolated to make it easier, to skip more steps. So y is equal to 8 times 1 minus 12. So that's just 8 minus 12. And so that equals to negative 4. And so we have the answer. And as you can see, we can solve it with either method. It's all just a matter of preference and which one you like to do more. Are there any questions?
All right, we're gonna do one more problem before we get into our Kahoot to end this lesson. So we'll give you guys 2 minutes to clear solve this one as well.
All right, so should be enough time. Here's our problem. So for this one, I chose to solve it using substitution. Maybe you guys use elimination. Again, it's a matter of preference and what you guys see first. So for here, I solved for x. We took this equation, manipulated it, and isolated x on one side. So we just added x to both sides first to move it over to get a positive value. And we just subtracted 5 from both sides to isolate it. Then after we isolated x, right, since we know that these two are equal, once again in substitution, we plugged them into the, the other equation. And then we ended up with only values of only y variables, and we got rid of all the x ones. So with that, we plugged the thing in here, right here. And after that, we just distributed it. We ended up with 20y plus 20 plus y is equal to -7. Forgive my bad handwriting. And then we just simplify that, and we turn it into -27y plus 20 is equal to -7. And then we isolate the y variable. We end up with -27y is equal to -27. And from that, it's clear to us that y is equal to 1. Once you have the y variable, we then plug it into the original equation again. And we have -x plus 7 is equal to 5. And if you guys need to, you can subtract from both sides. So 5 minus 7 is equal to -2. And then -x would equal to -2. And then from that, we can tell that x is equal to 2. Are there any questions?